Hi, this is Neil Underwood, or SpaceXULA, and welcome to another episode of Still Extruding. In this one, we're going to be covering the calibration of the x-axis of a RepRap. This is going to be the same procedure you would use for the x, the y, and the z, so I'll go over briefly at the end how you'd also do it for the y and the z. You would also need to calibrate your e-axis, but that'll be a separate video just because it's a little confusing to some people. This is going to assume that you're using a RepRap firmware, so either at this time Sprinter, Marlin, ScribbleJ, any one of them that use the configuration.h style setup. It's also going to assume that you're running a RepRap, but you could be running another type of machine off of the RepRap firmwares. So first thing you're going to do is open up your firmware in the Arduino IDE, go to configuration.h, and you're going to get your steps per millimeter for your X, your Y, and your Z axis, which will be right here. First number is X, second number is Y, third number is Z. You don't have to leave the Z number in that format. You can simplify it by doing the 8200 divided by 125 and use a straight number like the other ones. Doesn't really matter which, whether you use what type of number you use there. So once you get your number for your x-axis, you go ahead and measure how far it moves. Okay, once we've got our steps per millimeter out of the Arduino IDE, which it's currently saying 43 steps per millimeter. Now we need to find out how many millimeters it does actually move whenever you tell it when it moves 43 steps. So the easiest way to do that is go ahead and start Pronter face up. Get your motors off. Slide your X carriage all the way over. Grab your handy dandy calipers, zero it out, make sure it's in millimeters. Measure from the motor end of your X axis right here to your carriage, zero it out. So zero it out at that distance. Then you're going to go over here and tell your X axis to move negative 100. So it thought it moved 100, but it actually only moved 5337, as you can see here. So what we're going to do is just conversion factor. You're going to do 43 steps per millimeter. It actually moved 53.37 millimeters times 100. Now, once we take this number, divide it by, take the number that it thinks it moves steps per millimeter, then you divide it by the number it actually moved when you told it to move 100 millimeters times 100. That will get you the new value that you need to enter into your firmware. Okay, once you've measured how far it moves, you do your calculation in the calculator and you get your new steps per millimeter value, which for this one will be 80.569. So you will paste in 80.569 for your X, and since usually the X and Y are the same, it's safe to go ahead and put it in for Z, or you put it in for X and Y, but you'll need to double check the Y to make sure that is actually correct. So go ahead and save your changes to your firmware and upload again to your electronics. If you get a compile error, make sure you didn't get your commas and your periods mixed up somewhere in here. That is the number one easy way to mess it up. So make sure you didn't delete any commas. If for some reason you still have compile issues whenever you do this, I usually would just go ahead and go back to an older version of the firmware or re-download and alter it again. You should really get used to updating your firmware. Okay, now we've updated our firmware with our new value, which is 80.5696 on the x-axis. So we're going to repeat what we just did. on, make sure it's in metric, zero it out. Measure the distance, zero it out again, and now tell it again to move x negative 100. And you'll notice the stepper actually sounds different when it moves. We're going much further this time. And this time, when we told it to move 100, it moved 99.89. That is within an acceptable tolerance, but you want to try to get this as close as you possibly can. So 99.85 millimeters is how far it moved when you told it to move 100. So you're going to go the value you have currently in your cents per millimeter divided by how far it moved again, which is 99.85 times 100 again. Update your firmware again, and we'll see what we come up with. Okay, we updated the firmware again, this time to 80.6906. Zero out your caliper. X 100 minus. I usually do this 3 or 4 times for each machine. Ooh, bumped it. Okay. So for this time, it was within 0.1 millimeter, so I usually call that good. So now what we're going to do is I usually enter that value for both the X and the Y axis. So what I then do is drop my Z axis, let's just do this manually. So then I drop my Z axis all the way down. Put a dot on my build plate. And get your caliper. So let's put a dot there. Measure 100 millimeters from that. Another dot. The y-axis is really sort of hard to measure. You have to go under the machine to do it. So this is just the way I do it. Because the X and the Y value should be the same. So set it on it. And then do Y minus 100. Perfect. Okay, so the X and the Y value usually should be 100% identical. Next thing you do is the Z-axis. I'm not going to bore you through the step for it, but it is exactly the same. You just do it sort of inversed. So you measure from this point to this point from your Z-axis. Zero it out. Take the value out of your firmware. Then you're going to use the same process for this, but this time you're going to be measuring up to this instead of away from this. So you keep moving the firmware, moving the value for the step millimeter until this, when this moves 100 millimeters, it equals 100. This moves 100 millimeters in the firmware, it equals 100 in reality. And we're going to do a completely separate video for doing the extruder version of this. But you need to calibrate your X, your Y, your Z, and your E axis before you start trying to print with your machine, especially with the SchemeForge 40 plus firmwares. Hope this helped. Have a good day.